Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in a lecture number 2 of surface areas and volume. So, my dear friends, this lecture is going to be very amazing because in this lecture we are going to be discuss the formulas and questions. Okay, yes, so now let's start. So, here is today we are going to discuss surface area of cuboid and cube. Okay, so first of all, let's see what is cube and cuboid. So my dear friends, cube and cuboid are three-dimensional figures, as we know that. Okay, consist of 6 faces, 8 vertices and 12 edges. Okay, so now let's see first of all cuboid. So what is cuboid? Okay, yes, a cuboid is also called a polyhedron, having 6 faces, 8 vertices and 12 edges. You can see here is this is what this is the cuboid. The faces of the cuboid are parallel to each other, but not all the faces of the cuboid are equal in dimension. That is the difference between the cuboid and cube. Okay, I hope you get this point, my dear friends. Okay, so in our everyday life we have seen many objects like cuboid. Like for example, if you talk about the example here is, for example, wooden box. Okay, wooden box and a matchbox, or we can say matchbox. Okay, I hope you get this point. So there are a lot of examples in our everyday life. I hope you get this point, my dear friends. Okay, yes, so now let's talk about the properties of cuboid. Okay, yes, so first properties, let's we are talking about the faces of cuboid. Here is faces of cuboid. Now what are the faces of cuboid? If you see in the figure, this is a cuboid. So a cuboid is made up of 6 rectangles. 6 rectangles. You can see here is. Okay. And each of the rectangles is called the face. Is called the face. In this figure you can see here is the first rectangle. We can observe this like A, B, F, E. Okay. This is first rectangle. And the second one is here is D, A, E, H, this rectangular piece. And the next one is D, C, B, A, D. Next one this is. Okay. And the next is D, C, G, H, D. Okay. And the next is C, B, F, G. Okay, this face. And the last one is H, G, F, E, H. So there are total, yeah, there are total 6 faces. How many faces? Yeah, there are total 6 faces of cuboid. So what are these faces? So we can write here as A, B, F, E, D, A, E, H, D, C, G, H, C, B, F, G, A, B, C, D and E, F, G, H. So these are the 6 faces which are present in the cuboid. So we can say that cuboid is made up of 6 rectangular faces. 6 rectangular faces. So here is A, B, C, D. This is what? This is top face. This is what? This is top face. And E, F, G, H. This is what? This is bottom face. So top face and bottom face. I hope you understand these things. So A, B, C, D means we can say that the roof of the room. Okay, so bottom is what? Yeah, and the bottom is this E, F, G, H. Okay, understand, my dear friend? Now the other 4 sides, like Here is ABFE, BCGF, CGHD and AEHD. Okay, so these are the opposite faces to each other. Okay, like ABFE is opposite to CGHD and AEHD is opposite to CBGH, or we can say that these are the like walls of the rooms, like walls of the rooms. So any two faces other than the opposite faces are called adjacent faces. We can say that any two faces like this face and this face, we can say these faces are called, these faces are adjacent faces. I hope my dear friend you understand these things. Yes, so now here is now the next we are considering as base and lateral faces. Base and lateral faces. Here you can see any faces of a cuboid may be called the base of the cuboid. Okay, the four faces which are adjacent to the base are called the lateral faces of the cuboid. Okay, let's suppose here is HEFG. Okay, this face is what? This face is like base. So the adjacent of this base, the adjacent face of this base is what? This is lateral faces. We can say this is lateral faces. Okay, and here in this figure EFGH represent the base of the cuboid, represent the base of the cuboid. So usually the surface on which a solid rests is known as the base of the solid, is known as the base of the solid. And what is lateral faces? The adjacent faces to the base, means the four faces which are adjacent to the faces to the base are called lateral face, are called lateral faces. Here is this is the base, and the four faces which is adjacent to this base like AEHD and ABFE and BCGF and CGHD. So these faces are what? These faces are the lateral faces. Okay, I hope you get this point. So here we can say that EFGH is what? This is the base of solid, base of solid. Now my dear friends, let's move on. Now let's talk about the edges of the cuboid. Okay, the edge of the cuboid is a line segment between any two adjacent vertices, between any two adjacent vertices. Okay, here is, or we can say the edge of a cuboid is a line segment between any two adjacent faces, or we can say it is also called. Okay, so here is, let's see, there is AB, this is the edge, AE, this is the edge, EF, this is the edge, and BF, this is the edge. So we can say that there are total 12 edges. There are total 12 edges. So we can say there are total 12 edges in the cuboid. So what are these? So they are AB, AD, AE, HD, HE, HG, GF, GC, FE, FB, BC, and CD. Here you can see in the figure AB, BF, FE, and EM. Okay, and the other are BC, CG, GF, HG, DH, DC, DA, and HE. So these are the what? These are the edges of this cuboid. I hope you understand these things, my dear friends. Yes. So now here is, you can see like rectangles. Here is ABFE is what? Rectangle, and in rectangle opposite, yes, opposite face, opposite sides are equal. It means AB is equals to EF. Okay, similarly AB is also equals to DC. AB is also equals to DC, and DC is also equals to HG. Okay, and HG is also equals to EF, and similarly DA is equals to HG, HE. Okay, DA is equals to HE, and HE is equals to GF, and GF is equals to CB. Got it, my dear friends? Okay, now let's talk about the vertices of cuboid. Vertices of cuboid. Okay, so the point of intersection of three edges of a cuboid is called the vertex of cuboid. Is called the vertex of cuboid. Here you can see the intersecting point of three edges, like this edge, and this edge. Then we get a point. So this point is called the vertex. This point is called the vertex or vertices of cuboid. It means A, B, C, D, E, F, G, H. So these are the vertex or vertices of the cuboid. Vertex or vertices of the cuboid. I hope, my dear friend, you understand these things. So we can say that a cuboid has 8 vertices. You can see 1, 2, 3, 4, 5, 6, 7, 8. So we can say here is a cuboid has 8 vertices. 8 vertices like A, B, C, D, E, F, G, and H. Okay, so these are the 8 vertices of the cuboid. Now, my dear friend, you understand these things. What is faces? What are edges? What are the vertices? Okay, and what are the base and lateral faces. Okay, now let's talk about the area, surface area of the cuboid. Surface areas of the cuboid. Okay, now let's suppose we have a cuboid like this. Okay, you can see here is. So now we know that cuboids are made up of the 6 rectangular faces. What is? 6 rectangular faces. Okay, so here is first of all area of face E, F, G, H. Means we are talking about this. E, F, G, H. This is what? This is rectangular face. And we know that the area of rectangle is what? Length into breadth. Okay, so this is what? This is length and this is breadth. So area of EFGH, and this area is also equals to the area of ABCD, because these two faces are opposite to each other and equal in areas. So we can write here as area of face EFGH is equals to area of face ABCD. This is equals to length into breadth. This is equals to what? Length into breadth. Now similarly, here is area of face BF. Okay, here is BFGC, means we are talking about BFGC, this face. Okay, and the area of this face is equals to area of AEHD. Got it? I hope you get this point, my dear friends. So now here is area of face BFGC is equals to area of face AEHD. So this will be what? Here is, you can see, this is what? This is breadth and this is height. So we can write here as B into H. Okay, now area of face, here you can see DHGC, area of face this DHGC. Okay, so the area of this face is equals to area of face ABFE. Okay, so here is area of face DHGC is equals to area of face ABFE. ABFE, and this will be what here is, you can see this is length and this is height. It means L into H. Okay, now we have the area of all 6 faces. Okay, after adding this we get total surface area. We get what? Yes, total surface area of cuboid. Okay, so my dear friends, total surface area of a cuboid. Total surface area of a cuboid is what? This is equals to sum of the areas of all its 6 rectangular faces. 6 rectangular faces. Okay, so here we can write as total surface area of cuboid is equals to, here is L into B. Here we have, here you can see, here if you observe this is L into B is the area of 2 rectangular faces. So here this will become, we can multiply it by 2 plus, similarly this is 2 into B into H plus 2 into, here is L into H. Okay, so after taking 2 as common, here we get LB plus BH plus LH. So this is what? This is TSA, means total surface area of cuboid. We can call it in short, this is TSA. I hope my dear friend you understand these things. Yes, so now my dear friend, let's talk about the lateral surface area of cuboid. What is lateral surface area of cuboid? Okay, yes, in this, now the sum of surface areas of all the faces except top and bottom. It means we are adding the area of 4 walls like ABFE, DCGH, ADHE and CBGF. Okay, here we are excluding the top and bottom. Okay, my dear friends, so here is LSA will be, here you can see area of A, area of ADHE plus area of, here is area of BCGF plus area of, here is ABFE plus area of, here you can see DCGH. What is DCGH? Okay, now here is area of ADHE. Okay, this is what? This is B and this is H. Okay, so this will be B into H plus area of BCGF. Similarly, this is B and this is H. So we can write B into H. Okay, plus area of ABFE. Here is, you can see this is L and this is H. So we can write L into H plus. Similarly, area of DCGH. Okay, so this is what? Same L into H. So here this will become 2 into B into H. Okay, 2 into B into H plus 2 into L into H. Okay, and from this we can take 2H as a common, so we get L plus B. So the lateral surface area of cuboid is 2H into L plus B. So LSA is equals to 2H L plus B. So this is what? This is the lateral surface area of cuboid. Okay. Now let's talk about the cube. Now what is cube? A cube is a three-dimensional shape that is defined XYZ plane. That is defined XYZ plane. It has 6 faces, 8 vertices and 12 edges. How many edges? Yeah, there are same 12 edges. All the faces of the cube are in square shape and have equal dimensions Okay, now similarly in this cube the total faces are what? Total faces are 6. How many faces? Yes, here is you can see A, B, F, E. Okay, and A, D, E, H. Okay, and C, B, D, F, and D, C, F, H. Okay, so these are what? These are the faces of the cube. Okay, and similarly G, H, F, E. Okay, so these are 6 faces of the cube. Now how many edges? So total edges are, there are 12 edges. There are total 12 edges. Here is AB, BC, CD and DA and DA, and the next one is AE, EF, BF. Okay, and FG and CG and GH and DH. Okay, so these are what? These are total 12. Yes, these are total 12 edges. Now let's talk about the vertices. So how many vertices? So there are total 8 vertices. Means there are total 8 corners in the, yes, in the cube. So how many vertices are? There are 8 vertices: A, B, C, D, E, F, G, H. Got it? Now here you can see in the cube all the faces are in the shape of square. It means all the sides of the cube are equal. All the sides of the cube are what? Are equal. Here is, if AB is equals to A, then we can say that all the sides of the cube are of A unit. A unit. I hope you understand these things, my dear friends. Yes, so now let's talk about the surface area of cube. Okay, surface area of cube. Now in this, here is, we know that length is equals to breadth. Okay, length is equals to breadth is equals to height. Means all the 3 dimensions are equal. All the 3 dimensions are what? Are equal. Okay, yes, suppose let, here is, let the length of cube is equals to length of an edge, or we can say length of a cube is A unit. What is? Yes, A unit. Then the total surface area. Okay, yes, so now, so the total surface area is what? So total surface area of cube is equals to, here this will become like you can see 6 into a square. It means 6a square. So this is what this is, TSA. Okay, means total surface area of cube, which is 6a square. Okay, my dear friends, I hope you get this point. Now let's talk about the lateral surface area of cube. Okay, now lateral surface area of a cube. Here in this, you can see in lateral surface area, we are covered just 4 walls. Okay, we are covered just 4 walls. So here is, you can see in this LSA. Okay, we can say lateral surface area means LSA of cube is equals to, here you can see area of ABFE plus area of, here you can see CGHD, area of CGHD plus area of AEHD plus area of CBFG. It means here is in the lateral surface area, we are excluding the top and bottom. Okay, so here is it. This will become like a square plus a square plus a square plus a square. Okay, so this will be 4a square. So we can say LSA is equals to 4a square. What is? Yeah, 4a square. I hope, my dear friends, you understand these things. Okay, my dear friends, so this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.